In Animator Friendly Rigging Part 3, we began to extend JJ's rig to handle arms and fingers. While doing this, we explored forward and inverse kinematics, set-driven keyframing, expressions, utility nodes, and creating complicated hierarchies in order to get interaction that's easy for the animator to use. In Animator Rigging Part 4, we're going to continue this process by rigging the legs of the character JJ. We're going to take a look at some other important elements of creating animation rigs, mirroring controls, snapping, UI creation, and additional rigging ideas. But first, let's go ahead and extend our JJ rig so he has legs and feet that are a joy to work with. Just as we did for JJ's torso, arms, and hands, we need to take a look at some reference for the legs to figure out what it is that a character actually needs to do and what our legs need to be able to do. If you look in the movies directory of the included files, you'll notice that there's a series of movies for creating, or for the legs, that we can use for reference. So if we take a look at the first one, this is Bryce, and he's running up a wall, running up to a wall, leaping onto it, and running off. And so let's take a look at what his legs are doing. As his legs are running up, it's just a standard, foot plant, swing forward, stuff like that. Nothing too complicated. Then when he swings up, his leg comes around the top, and you can see he pushes off with his toe. His leg extends, and then lands on the side of his foot. And he rolls around like this. The leg comes around, and now he's up on the toe, pivoting around, and pushing off. So we need to make sure that our legs can push off by the ball of the foot, swing around, and move in FK mode, and then land and keep going. In the second example, Carlos is doing push-ups, and you can see that his knees are locked down. So having the ability to actually lock the character's body, or lock the knees to the ground, is going to be something that's also very important. In this movie, Kevin is jumping up, planting his foot on the ground, and pushing off and rolling. And in the final movie, you can see that I'm running around, jumping, again pushing off with the ball of my foot, spinning the legs around. Here they go, sliding up on their heel. Foot comes around, lands on the side, pivots to go flat, and then I keep running off. So go out yourself and try running around for a bit, see what your legs do. Analyze how the force of the movement is coming from or where it's coming from. Is it pushing off the ground? Is your hip pulling your foot? Is it swinging from the thigh? There are a number of motivators for creating motion with your legs, and it's important to understand exactly what's driving everything. So remember, providing more than just locomotion, legs help convey force and drive. So based off of our reference, we can come up with some general leg motion requirements for our legs. First is inverse kinematics for general locomotion. We want to be able to put the foot wherever it needs to be and have the knee do the correct thing. It's also important to be able to lock the knee to the ground if necessary. We also need forward kinematics for specific situations, like if the character is jumping and the legs are just going to be flailing through the air. It's a lot easier to animate that using forward kinematics than it is to animate it with inverse kinematics. And finally, we need for a way to easily roll the foot. So having a foot roll and foot pivot system would be very, very helpful. So as we did in parts 1, 2, and 3, let's go ahead and take a look at the toolkit for what would be required for creating the rig. This gives us an opportunity to experiment, to practice, and try options before we actually commit to them in creating our rig. One of the first things we should try doing is figure out some way of creating a foot roll. This type of control is really going to help define how we actually interact with the leg quite a bit. So let's try a couple of ideas and see what we can come up with. First thing we're going to do is create a new scene, and then we're going to go to a side view. And we'll create a very quick leg skeleton just to work with here. So go to the joint tool, and then hold down X to just create, just to lock to the grid points. Click over here to create the knee, and then we'll click here for the heel, and then one for the ball of the foot, and then one for the toe. I'm going to go ahead and change the display of these joints here to try and make them a little bit bigger so we can actually see them better. There we go. And now we want to add some geometry to this. So again, we can use the script, this little shelf button here, to do it. So select all the joints, and then click on the little Add Geo, and that will automatically add geometry for us, as you can see. So now we've got geometry on our leg and skeleton rig. Let's go ahead and scale the feet so they look a little bit more foot-like. We'll just grab this one, and scale out the geometry a little bit. Grab the toe. We don't want to be scaling the joint, remember, we just want to be scaling the toe itself, the geometry. So make sure when you select it, you don't pick the joint. And we'll scale that, and there we go. So now we've got a foot that looks a little bit more like a foot for us. Our next step is to create some IK handles for the leg because this is going to be a leg rig. So what we want to do is create an IK handle going from the hip to the foot, and then for the foot to the ball, and from the ball to the toe. So we'll go skeleton, IK handle tool, bring up the option box. We're going to set our current solver to IKSC solver for now. Just because we're working on the foot roll, we don't need to worry about where the knee is. So we'll go from joint 1 to joint 3 to create an IK handle. And then we'll do the same thing from the foot to the ball, and then from the ball to the toe. So now we've got 3 IK handles here. One that will control the heel, one that controls the base part of the foot, and then one that controls the toe. Just like that. Let's go ahead and rename everything so it makes sense, because right now everything doesn't make sense. So joint 1 is going to become up underscore leg. Joint 2 will be low underscore leg. Joint 3 can be foot. Joint 4 will be toe. And joint 5, toe, end. And then we'll change the name of the IK handle 1 to be leg IK handle. IK handle 2 is going to be foot IK handle. And 3 will be toe IK handle. Okay, so notice if we select all 3 IK handles, we can move them together, and that will move the entire foot, which is great. But we want to make that easier for the animator because obviously selecting the individual IK handles is not a good workflow for animating. So we're going to create a locator here that we'll just make for the foot. So we'll go create locator. We're going to name this foot underscore loc, and then we'll parent the 3 IK handles to the foot locator like so. So I can just grab the foot locator and move that around. Now just like we did for the hand pressing, what we want to do is create a locator right over here that we'll use to lift the ball of the foot up. So we'll go create locator, and we're going to call this ball underscore loc, and then we're going to place it right where that joint is. So if I hold down B or V for point snap, place it right there, and then we're going to parent ball loc underneath foot loc because we want to make sure that this ball locator moves around with the foot like so. And then we'll parent the leg IK handle underneath the ball locator so that when we take the ball locator and rotate it, it rotates the foot around like the ball. This is just like how we did for the hand control. So it should look very, very, very familiar. Now, we want to do something similar for the toe of the foot because, again, just like how we saw in the reference, sometimes you'll be lifting up on the ball of your foot, sometimes you'll be lifting up on the toe of your foot. Usually you'll be doing a roll, which will do a little bit of both. So we'll create another locator. We'll call this toe loc, toe lift loc, and we'll place that right there at the end of the foot, like so. And then we're going to parent that underneath foot locator. And then we'll take all of the IK handles and the locator for ball loc and parent that underneath toe lift. So if I take toe lift now and rotate it, that will take the entire foot with us. I can take ball and rotate that, and then toe lift, and that. And there we go. Very, very simple foot rig for rotating from the ball and from the toe. So currently this system works really well for rolling forward, but we also need the ability to rotate backwards as if the character is putting the heel down. So we want to create a heel locator. So again, create locator. You'll notice that we're just creating locators for basically every type of control that we want to use. And then later we're going to set up controls for the animator, make it easier for them to work with it. So we'll name this new locator heel loc, and we're going to parent, again, heel loc to foot loc, like that. And we're going to parent the toe lift locator to heel locator. And now we've got the heel locator that will do this, and then the toe lift loc, which will do that. So we now have a system of locators where we can lift the foot on its heel, lift the heel up onto the ball of the foot, and lift the whole foot up on its toe. But imagine trying to animate with this. It could drive you totally crazy. There are too many things to try and select, so just as we simplified things for the hand rig where we added attributes to the hand control for bend and side, we'll do the same thing for the foot. Okay, so we're going to create some attributes on the foot locator. We'll go over here to foot loc, and what we're going to do is add some attributes. So select foot loc, and then we'll go to the add attribute button on our shelf. Poink, right there. And we're going to enter the names of the attributes. So what we first need is we need a heel lift, so we can lift the heel up. We need a ball lift and a toe lift, like that. And that'll just add those attributes to the end, right there. Now we're going to connect the heel lift, ball lift, and toe lift attributes to the actual locators themselves, because right now, as you can tell, they are doing absolutely nothing. So we'll bring up the connection editor under Window, General Editors, Connection Editor, right here. And I'm going to turn off Show Non-Keyable, so all we get are the keyable attributes there. And then we'll select the heel locator first, click Reload Right. We want heel lift to connect to the Rotate X. So when we select foot locator, there, and we do heel lift, it'll rotate there on the heel. Then we're going to connect ball lift, and we'll go down to the ball locator, reload right, connect that to the rotate X. And then we'll do the same thing for the toe lift. Toe lift, reload right, rotate X. So now on the foot locator we've got heel lift, we've got ball lift, and we've got toe lift, all working together. Let's go ahead and save this file as the foot toe, what are we going to call this? Why don't we call it Foot Toolkit version 1. So in our work in progress directory, we'll just call this Foot Toolkit v1.ma. Now I've used rigs like this before where you've got a ball lift and a toe lift and you're able to work together to make sure the foot rolls correctly, and you've got a heel lift to go back. But one of the problems is that when you're using heel lift, ball lift and toe lift really don't mean anything. You don't need to use them. And when you're using ball lift, you really shouldn't be using the heel lift because the heel's down there. So since you've got these competing controls that should be used exclusively or independently from each other, it might be a good idea to actually remove this problem from the animator where they have to worry about overlaying the heel lift and the ball lift and stuff like that, and give them instead just one control called roll, which will allow them to just go from the heel to the ball of their foot. Let's go ahead and do that just to see what it's going to look like. The first thing we need to do is break the connections on the heel locator and the ball locator, and we'll do that by selecting them and then going right mouse button, break connections in the channel box. Then we'll go back to our foot locator, and we're just going to delete the heel lift and the ball lift attributes by choosing right mouse button, delete attributes. And we're going to add a new attribute to the foot locator called roll, like that. Then what we'll do is use roll to set up a set-driven key relationship to the heel and the ball. So if we select heel and ball and choose animate, set-driven key, set, those are our driven objects. Foot locator is going to be the driver, and we'll choose the roll attribute to affect the rotate X of the heel and the ball. Right now roll is set to 0, so we'll set a key for that. Then we'll set roll to -20. And you imagine that when roll is set to -20, the heel should probably be rotated back about like that. So we'll set a key there. Then we'll go back to roll and we'll set it to 20. And we'll take the ball and we'll bring that up to about like that. And we'll key that. Now if we take this roll attribute and we go back and forth, you can see that the roll does exactly that. It goes up on the heel and then up onto the ball. And that is much easier for the animator to work with. Then if they want, they can take the toe lift and incorporate that as well. So that all works together very, very easily. So that works pretty well, but we could simplify it more. We could also include the toe lift if we wanted into this entire thing. But then every time the animator wanted to roll the foot, the toe would lift at exactly the same point. They may not want the toe to always lift when the ball is bent to a certain degree. And with a set-driven keyframe relationship, there'd be no way for them to modify the point that the toe would start to lift up. So does that mean that we shouldn't look for a way to make this into one action? No, not necessarily. What we want to do is develop a foot roll that'll work most of the time and allow the animator to change the point at which the ball leaves the ground and the toe lift starts to happen. That way, most of the time they can just roll the foot and not have to worry about it. But if they want to make it so that the foot rolls to up here, or the ball gets up here before the toe starts to lift, they can. Or if they want to make it so the toe starts to lift when it's here, they can. But in general, they'll have a very consistent, easy to use interface. So to determine how to do this, let's go ahead and examine all the different stages of a foot roll and see what they are. So stage 1 is the foot is back on the heel, like this. That's stage 1. Stage 2 is where the foot is flat. Stage 3 is where the foot is up on the ball. Stage 4, the toe starts to lift up a little bit, the ball is still bent. And stage 5 is the foot is straight, but the toe is completely lifted up, like that. So stages 1, 2, and 3 are all unique events, meaning there's no ambiguity about when they happen. When the foot's on its heel, that's all it can be doing. It can only be up on the heel. Like that. When it's on the ball, it's on the ball. And when it's flat, it's flat. There's no really ambiguity about that. But stages 4 and 5 are a bit ambiguous. Ambiguous. Meaning that they can occur almost at any point. How bent is the ball of the foot when it starts to go up on the toe? Is it at a value of 12? Is it a value of 30? Is it a value of 45? You know, what about when the foot's all the way up like this? Is that when it starts to happen? We don't know. And that's what I mean by these answers being ambiguous. We don't know when the toe lift should start to happen and when the foot should straighten out. So let's go ahead and provide a way for the animator to create that and make it so that's not ambiguous, and make it so that we can create a system that'll work with it so they have one control, a roll, but they can change when the stage 4 and stage 5 happen to make it whenever they want, basically. Now before we go modifying this, let's just reset everything back down to 0, and we'll save the scene as the next step here. So File, Save Scene As, Foot Toolkit number 2. And what we're going to do is develop a method that's going to allow for this type of interaction. We're going to have 3 different attributes that the animator can control. The roll attribute that they have now, and then we'll have a toe lift and a toe straight. Roll will do exactly what it's doing right now. It'll roll back and forth just like that. Toe lift, instead of actually lifting the foot on the toe like that, is going to be the value that the roll will be at when the foot starts to roll up onto its toe. For example, if we go like this and we say we want the foot to start rolling up onto its toe when roll is set to a value of 14, that's what we'll set toe lift to. And then as roll moves past 14, it will start to lift up onto the toe. Okay? We're also going to have a value called toe straight, and that will be the value that roll is going to be at when the toe straightens. So if we get to a value of 14 or 15, and then the ball starts to go up like that and we start to get toe lift, what we can do is when we hit a value of toe straight for an attribute of, say, 20, what that means is that when roll gets to 20, the foot will look like something like that. Okay? And that'll be when it straightens out. So with these 3 attributes, the animator should be able to animate a foot roll easily with one attribute, but also be able to modify the default behavior of the foot roll with the extra 2 attributes. So let's break the connection on the locators, and we'll create a better foot roll. We select heel locator, toe lift, and ball. Go to right mouse button and rotate X, break connections, just like that. Now let's add a toe straight attribute to foot locator. So come here, toe straight, like so. Now we've got toe lift, roll, and toe straight. So the next step is to get these attributes to drive the various rotations on the locators. In order to make this type of control easy to understand, we're going to use an expression to set up the behavior, and this will let us try things really easily. So we got to create an expression. So go to Window, Animation Editors, Expression Editor. and we're going to create a brand new expression. And what we want to do is first get the value of the foot roll itself. So we'll get the roll value, and we're going to put it into a variable. Roll is equal to foot underscore loc roll. Click create, and that's called expression 1. We're going to rename this to foot roll expr. And then if we go to select filter by expression name, you can see there's our foot roll expression, so we can keep working on it. So now we're going to add the heel control in here. So we're going to say heel underscore loc rotate x is equal to $roll. And if we edit that, now we go in here and play with the roll, you can see that the heel will move as the roll moves back and forth. But the problem is that the heel is connected all the time to roll. So as we go like this, even when roll is going positive, the heel will keep rotating. We only want heel to be gotten when roll is in negative, and that will pull the heel up. So how do we do that? We can use the clamp command to do this. What clamp does is you give it two values, a minimum value, a maximum value, and then an input value. And it will look at the input and figure out what's going on, and if the input value is between min and max, it will return that value. If it's below min or above max, it'll just return the maximum value. So you can see in this graph here, this curve here represents the input value over time. These hard lines represent the maximum and the minimum. And this shows us the result that we get. So anytime input is between the min and max, that's the value we get. Over here, as soon as we hit max, we're always just going to be getting this maximum value until the input value drops down below max, and then it goes down, and then boom, the input value drops below minimum, so now it's just going to return minimum, and then all of a sudden it's back in between the two again. So let's take a look at some examples. Here we've got a clamp of 0 and 5, which min and max, and an input value of minus 20. The result for this is going to be 0 because minus 20 is less than a minimum value. In the next example, we have a value of 0, 5, and 10. In this case, we'll be getting 5 because 10 is greater than the maximum value. And finally, we have 0, 5, and 2. So 0, 5, 2. 2 is between the two of them, so we're going to get a value of 2. So that's how clamp works. Remember, first value minimum, second value max. Third value is the input value, and then it will return anything between these two, or the minimum or the maximum, depending on what the input is. Okay. So let's say we wanted to use the roll value in our expression, but only return values less than 0, and then clamp the value at 0. We can use a clamp command like this. Clamp of minus 180 to 0, so that's the minimum, that's the maximum, and roll. So if roll is less than minus 180, it's only going to return minus 180. If it's anywhere between negative 180 and 0, it will return whatever the value roll is. And if it's greater than 0, it's going to return 0. But the problem with that solution is that we're now limiting roll to only be allowed to be anywhere between minus 180 and 0. What happens if we want it to be more than minus 180? What if we want it to be minus 360 or minus 2,472? We'd always type in a really, really high value here, make negative 18 billion or something like that, but you never know what value the animator is going to want to use. So we shouldn't really limit it like that. Instead, we can do something like this, where we get the absolute value of the roll. So if it's negative or positive, it doesn't matter. We just make sure that it's always going to be a positive value. We multiply that by negative 1, so it's always negative. And then that's going to be our minimum. So whatever roll is currently at, as long as it's negative, that's our minimum value, and that's what it will return. Our maximum is always 0. So roll, if it's ever greater than 0, is always going to return 0. So we could do an expression like that. But this will give us what we want, but it seems like a lot of work to simply say clamp the value at 0. And in order to get that value, what we're actually doing are three different things: the absolute value of roll, the multiplication, and the clamp. So that might actually take a little bit of time to evaluate. And if you have a whole bunch of these in your scene, it'll run a little bit slower. So there might be something that's actually a little bit faster. And if we glance through the various mel commands that we can use, there is one we can use called min. And what that does is give us a minimum value and an input value. So, sorry, it actually gives us it returns the smaller of two values. So the first value and second value, whichever of those is less, that's what it's going to return. So if roll is set to -10, and that's 0, then we'll get -10. If roll is set to 40, and that's 0, we're going to get 0. Exactly. So that is something we can use. So let's go ahead and modify this expression to use the min command. So we'll say heal loc rotate x is equal to min 0, comma, roll. Like that. Edit. Now when we use roll, it only goes negative. Notice when roll goes positive, we don't get anything. Nice. That's exactly what we want it to do. Cool. And it can go back to whatever value we want. Fantastic. So let's go ahead and add the ball in there. So the next thing will be ball underscore loc rotate x is going to be equal. Now we want ball to get anything greater than 0 for the roll. And luckily there's a command called max. So again, max 0 roll. And that will return the greater of these two values. So now if we take roll, go back and forth, and there we go. You can see we're getting the exact behavior that we want. Sweet, let's continue on with the expression. What we want to do is add in the toe lifting. So to find out when the ball or when the foot starts lifting up onto its toe. To do that, we're going to put a value for the toe lift to see where it is that we want the toe to start going up. Let's say a value of 45, because if we take the roll and we go like this, as we hit 45 degrees, this is where we want the toe to start being taken into account, right about here. Okay? So let's go back to our expression here. And this is kind of what we want to have happen. So at 0, this is roll. At 45, we want the toe to start lifting. And then by the time we hit 90, we want the foot to be straight. Okay? So notice that at 45, the foot is at a 45-degree angle. And at 90, the foot's at a 90-degree angle. This is very, very important. We have to make sure that the foot's angle matches what the animator sets in roll. Otherwise, the foot's motion is not going to be predictable. So we need to make sure that this happens in a very, very predictable and easy way. Okay? So what kind of math can we use to get the value of toe lift, locate, or rotate x to increase from 0 when roll is at whatever the toe lift value is to the same value of roll when toe is straight? This graph might help make it a little bit easier to understand. So we've got the roll value, which is going to be constantly moving like this. We have the toe lift value that will start around here, and as roll increases, the toe lift itself, the toe has to go faster until we hit toe straight value, which is right there, and then everything's going to move together. Okay? So the red line represents the motion we want toe lift to take, and so you just notice here how it increases from there to there in order to ensure that it lines up correctly. So one thing we're going to do is we're going to try this function called lin step, and it works like this. You give it a minimum value and a maximum value and an input value, just like clamp. It's very, very similar, except instead of returning the minimum or maximum value, it returns a 0 to 1 linear representation of where value is in between min and max. And I know exactly what you're thinking. Is what? And it's actually much more simple than it appears. Let's see if I can show you some examples to help make that make more sense. Here we've got a couple of lin step commands. So we've got lin step 010 minus 1, 010 0, 010 1, 010 5, etc. Remember, this is the minimum value. Second column is the maximum value. Third column is the input value of what we're giving it. So if we have a lin step of 0 to 10, 0 being minimum, 10 being max, and negative 1 is the input, the result we're going to get is 0, just like clamp, because negative 1 is less than 0. If we have 0, we're still going to get 0, because 0 is going to be the same as 0. If we have a value of 1, 1 is between 0 and 10. With the clamp, this would return a value of 1. But with lin step, it does the same thing as clamp, except it normalizes that answer, between 0 and 1. So our result would be 0.1. If our incoming value is 5, that's going to be halfway between 0 and 10. So our result will be 0.5 as opposed to 5. If we have a value of 9, that's going to be 9/10 of the way through, or 90%. So our result will be 0.9. If we give it a value of 10, the result is 1. If we give it a value of 15, the result is 1. So here in the graph, you can see this pink line here represents the incoming value, This blue line represents the normalized value of what we get. So linstep works pretty well, but the problem is we don't want values between 0 and 1. We want the values to go between 0 and roll, and whatever that value is. So how do we do that? Well, if the output is from 0 to 1, we can multiply the output by roll. That way, if the result is 0, we still get 0, but the output's 1, we get whatever the roll is. So this is what the expression would look like. Linstep, we get the toe lift, which is our minimum value, toe straight, which is going to be our maximum value, and the roll, and then we multiply that by roll itself. This means that when roll is less than the toe lift, it will return 0. When roll is when roll is greater than toe straight, it's going to return 1. When it's between the two, it's going to return a linear result between the two, growing from 0 to 1. And whatever the result is, we multiply that by the current roll value to get roll. So as soon as toe straight is hit, the roll value, the toe lift rotate x, is going to be the same as the roll value. So let's go ahead and modify the expression to try that. See if we can make sense of it. We'll set the toe straight value to 90, like that. And the first thing we need to do is get those values. So we're going to choose toe lift is equal to foot loc toe lift, and toe straight is equal to foot loc toe straight, like that. Now we're going to add that linstep expression. So toe lift underscore locator rotate x is going to be equal to linstep toe lift toe straight roll times roll, like that. Edit. Okay, so let's see what happens now. As I take roll and move it, the heel does that. As soon as roll gets to 45, notice how the toe is coming up. But the problem is that at toe straight at 90, that's fine. That's exactly where, when roll is at 90, the toe lift locator is going to be at 90. But the ball locator itself is still rotating through all of this. We need to tell the ball locator to stop rotating once we hit the value where the ball comes, or when the foot starts to lift up the toe, and we get to where toe straight is. We need to make sure that the toe locator, the toe lift locator, is totally straight. So that's kind of a problem because ball locator is a child of toe lift loc, so it's just going to keep on going. So we need to come up with some way to get that to go straight. So how do we get the ball locator rotate x to go back down to 0? In effect, we want ball locator rotate x to increase from 0 to whatever the roll value is up until roll is the same as the toe lift. So we want ball locator x to be rotating up until toe lift, or up until roll is equal to 45. Then, as roll increases to toe straight, we want ball locator rotate x to go back down to 0. Like this. This blue line is our roll value. The pink line is what we want the ball locator rotate x value to do. It increases up until we get to 45, and then it's going to decrease down as we approach 90. So again, using linstep, we can get this to work, but we kind of need to break it up into two different sections so we understand what's going on. The first part is where the rotate x for the ball locator is going to grow up to be the same value as roll, and the second part is where it's going to drop. So part 1, we have linstep of 0, and then toe lift is so 0 is our minimum, toe lift is our max, roll is the input value, multiply that by roll. Same thing basically that we saw for the toe. Then on part 2, we have something completely different. So in part 2, we're inverting the entire thing so that when the result is 0, we get 1, but when the result's 1, we get 0. Okay? And then we multiply the two together. It's a bit confusing, but you'll see as we get going what happens. So here we're going to change the expression for the ball locator rotate x. So the first part is going to be linstep 0 is the minimum, toe lift is the max, and roll is the input value. Then we're going to multiply that by the inverse of it. So 1 minus linstep, toe lift is the minimum, toe straight is the max, and roll is the input. And then we're going to multiply that whole thing by roll, like that. Okay, so now as we increase roll, ball locator rotate X is going to be going up until we hit roll being 45, the same value as toe lift. And now as we increase up to 90, you can see that ball locator rotate X starts decreasing until it hits 90, and then it's set to 0. See how that works now? And the nice thing is that we can change this whenever we want. So we could set this to be 70 when the toe starts to happen. So our roll works like that, and then at 70, whoop, it goes up onto the toe. So it's really up to you as the animator to figure out where you want this to be and at what point you want the toe to be straight. Maybe it's at 75, you want the toe totally straight. So it's only between those 5 units where it goes poink and comes back up, like that. Okay? So we have a foot roll system that'll give us one control to roll the foot and then 2 options for how it works. This gives the animator a lot of control. But it's pretty complicated. And is this complicated foot system really necessary? Well, that's for you and the animator to decide. If they want a more manual approach, you can always resort back to the single foot roll that just drives the roll and the ball lift, and then let them animate the toe lift themselves. That's totally fine. I've animated a whole bunch of shots with that type of simple method, and it works great. This method works as well. It's really up to you. The main reason I wanted to show you this was to talk about various options for doing what's normally a standard foot roll system. Okay? Let's go ahead and save this version as version 3. Save scene as Toolkit version 3. And if this is at all confusing, don't worry, the documentation explains it all in very, very high detail. So you can go back over and read it and read it and read it until you get it. And again, if it doesn't work for you, that's totally fine. There is no perfect system that works for everything. Just use what you like. Now let's go ahead and talk about the knee controls, because we need to have some sort of ability to lock the knee to the ground. This is pretty easy to achieve with the stretchy IK system that we used on the arm, but there's a problem with the whole pole vector constraint methodology that's used on the arms. You have to keep selecting the pole vector and move it around. There's got to be an easier way to deal with spinning the leg than grabbing a knee control and moving it, right? Right? Yes, there is. It's a method of rigging a leg called quote-unquote no flip, which basically means that if you lift the leg up in front of the character, it won't flip out, something that happens quite easily when using the pole vector constraints. Let's go ahead and convert the leg to a pole vector constraint and take a look at what it is I'm talking about. If we go over here to the leg IK handle right there and bring up the attribute editor, we want to switch the solver. Right now it's using a SC solver, a single chain solver. Let's go ahead and switch it over to a rotate plane solver, which will allow us to create a locator constraint, our locator, and use it as a pole vector. So we switch to a rotate plane solver. Now let's create a locator for our knee. So we'll create a locator, and we're going to move it just so it's sitting out in front of the leg right over here. We'll rename it to knee loc, like that. And now we'll select the knee locator and the leg IK handle and go constrain pole vector. And as you know from the arm, what that lets us do is move this to control where the knee is pointing, which is great. However, here's the problem. If we take the foot and we do what feet normally do, which is start moving forward, as soon as we go past where that knee is, the leg flips because now the pole vector is on the other side. It crosses that line that goes from the end effector to the root of the IK handle. As soon as we cross that, boink, the knee points the other direction, which is a real pain. So how do we create a leg that's less likely to flip? Well, what we can do is put the pole vector somewhere that the leg isn't likely to go, which means it's going to be less likely to cross the line. So notice that when you're walking, your legs go front and back quite frequently, but it's less likely that they go all the way out to the side unless you're doing the split. So what if we put the pole vector out to the side instead of being in front of the leg? Then we're going to be less likely to cross that line. So if I just come over here and I take the pole vector, move it all the way over to the leg, notice that the knee is pointing off to the pole vector. That's fine. What we'll do is we'll go over to the pole vector, or to the IK handle itself, and we're going to change the twist value to be -90. Now the twist will be pointing forward. And what that means is or the knee will be pointing forward. And what that means is that now as we go like this, the knee isn't going to be flipping out as much because the pole vector is aiming off to the side, and we've told the leg that that's okay, and that's the way we want it to work with. But what happens when we turn the foot? Will the knee do what's expected? If we grab the foot locator and rotate it, we notice the knee's not following. Now this is pretty bad. You want your knee to follow with your foot. If you actually go ahead and take your feet and rotate them and move them around, you'll notice that your knees tend to follow pretty closely to what your feet are doing. So we need to find some way to get the knee to follow. The other thing you'll notice is that as we're twisting the foot here, our rotation order on our foot control is incorrect. And remember, this rotation order is very important to make sure we get correct. So the first thing we'll do is we'll change our rotation order. Because this is a global positional control, we want to make sure Y is the best, or is the most important rotation. So we'll just change to ZXY over here. And you can either do ZXY or XZY. It's up to you. Okay, so now when we go like this, the foot's rotation order is correct, but we need the knee to follow. So if we take the knee locator, if we take the knee locator, what we want to do is we want to parent it to the foot locator so it follows with the foot. But if we do that, it works great as long as the foot's moving. But if we start doing things like roll, then it's not necessarily following the heel. And what we really want to do is have it follow what the heel is doing, because we could do something like that and then it's going to start doing all sorts of crazy stuff. So what we really want is the knee locator not to follow the foot locator itself, but to follow where the heel is. So instead of parenting it there, we're going to parent it to ball locator. So now as we roll like that, the knee locator is going to follow along with it. This is great, but we still need another control because we need to be able to twist the knee. If you're going to have the character running off to the side or turning very suddenly, you want to be able to take the leg, bend it like this, and then take the knee and lead that motion with the knee coming off over this way. So we need a control to allow that. We don't want the animator to have to actually grab the knee locator itself and work with it. So and pull that around basically. We don't want to have to deal with that. We just want a control on the foot locator that'll allow us to twist. So let's go ahead and create a twist attribute and then figure out how to hook it up. So we'll go here and add an attribute to footlook called twist, or knee twist, so we understand what it is. And now we need to see what it is that we can hook up knee twist to that's going to make the knee do the right thing. Well, what we can do is we want the knee locator itself to orbit around where the ankle is, right? So what we can simply do very, very easily is we'll take the heel locator and we're going to duplicate it like that. We'll delete all the children because that's at the heel there. And we're going to name this knee group. Okay? Then we're going to parent knee locator to the knee group, and we'll parent knee group back to the ball locator. So that now we've got this control, knee group here, which can rotate around, and that will spin the knee. And it also follows the foot exactly how we want. So as we roll like this, we take knee group, we can rotate around that foot correctly. Okay, so let's go ahead and hook up that attribute, and we'll do that in the connection editor. So Window, General Editors, Connection Editor, like so. We've got the knee twist, we go to the knee group, reload that, knee twist is going to go to the rotate Y, close. So now we can take the foot, we can move it, then we go to knee twist, and it will twist the whole thing around just like how we are wanting it to. Let's go ahead and save this. Save scene as. We're going to call it Foot Toolkit version 4. Okay, and we've got a good basis now for handling our leg rig. We kind of know what we're going to do. So let's go ahead and start creating the leg rig for JJ. Alright, so it's time to give JJ the legs he's been waiting for. Let's go ahead and load up the latest leg rig, or the latest JJ rig, which will be JJ rig version 4. And let's go ahead and display the leg. So if you open up JJ Group and then the geo, you can see the left leg geo will unparent that. So there's his leg for us to work with. And we can figure out what we're going to do. Let's go ahead first and create a skeletal structure for the leg so we can do exactly what we did before. Go to a side view here, and we'll create a very similar leg to what we created earlier with our test. So go skeleton, joint tool. We'll create a leg or joint for the hip, the upper leg. Create one for the knee, like that. Create one for the foot on the heel. Then for the ball of the foot, and then for the toe, like that. Now if we go to a perspective view, you can see that the leg is just directly in the middle there. So we're going to slide it out over to the side so it actually lines up with the foot geometry itself. Now we want to name the joints because having joint 1, joint 2, joint 3, and joint 4 are not going to work for us. So this one will be L underscore up leg underscore joint. Remember to follow your naming scheme that you've been using throughout the entire course. And we'll do L low leg joint. Looks like I've got an extra L in the up leg there. This one is going to be called L foot joint. This is L toe joint. And the last one will be L toe end joint, like that. Now let's go ahead and break up the geometry so that we can make sure the leg is segmented correctly. So if we select the geometry, and we're going to hit F8 to go into component mode, make sure that we're only picking faces. So we click on that button right there, and select the faces on the leg so they're segmented into up leg, low leg, foot, and toe, like this. So we select these guys, and if we zoom in closer, make sure that we've got the right selection over here. Grab those. That's a bit much on that side, so we'll pull back a little bit. Oop. Make sure we don't have any of these ones in the back that we don't want. Like that. Need that one. We'll just grab those two as well. Actually, we won't grab those. We don't want them. Okay, cool. So there's the knee. Then we want to grab the foot. So we'll add in these joints over here. Get a little bit closer. Make sure to remove these points that we don't want, like that. Actually, we should probably grab those guys. So we'll add them in. Woo. Make sure we've got everything on there. Cool. And around the heel, we've got everything we want there. Great. Okay. Cool. Then we go to our polygon, mesh, extract. That, which will separate them out, and then edit, delete by type, history. Now we want to parent each of these to the appropriate joints. So if we select them, just go ahead and parent them to the correct joint by hitting F8 to get out of component mode. Parent. Parent this one to that joint. Parent. This one to this joint. Parent. And that one to that joint. Parent. Cool. Now, unfortunately, the names of these geometries are very confusing. It's polysurface 3, polysurface 1, polysurface 4, polysurface 2. So if we go up here to our shelf when we have those selected, and we want to choose the rename geo, which is this button right there, it'll rename them to match the parent. So now we have L toe geo, L foot geo, low leg geo, and up leg geo. Let's go ahead and save this file, save scene as, and we'll call it foot rig v1. Okay, now that we have the basic leg set up, let's start making the controls. The first thing we want to do is start with the forward kinematics leg, as it's the most simple to set up, and we'll start by using the leg we've already got as a starting point, so we can be sure the positions and everything are exactly the same. So we'll select the L up leg joint right there, and we're going to click on the grep rename button up on the top of the shelf. Remember, this is the thing that lets us duplicate the current rig and also search and replace names. So under search for, we're going to search for L underscore, and we're going to replace that with L underscore FK underscore, like that. Then we're going to turn on duplicate and click go. And what it does is it duplicates the FK, the joints themselves, and gives us the name L underscore FK as opposed to L underscore. But it also duplicates all the geometry. So we'll delete that extra geometry. And now we've just got a leg rig that is perfect for the FK controls. So now that we've got an FK joint structure, we need to make a matching IK joint structure. That way we'll have two types of controls, FK and IK, and then the resulting joint structure that contains the geometry. So let's create the the IK joint structure. And again, we'll click on grep rename, and this time we're going to search for FK and we'll replace it with IK. And we'll choose duplicate, make sure LFK up leg joint is selected, click go, and now we've got our IK joint structure. So as I mentioned a few moments ago, we're going to have the FK joint structure and the IK joint structure drive the resulting joint structure, which is the regular leg control there. And in order to do this, we need to give the animator a way of determining what mode they're in, either IK or FK, just like we did with the arms. So we're going to set up a control so the FK leg and IK leg drive the resulting arm by going to the settings, anim, right here. And we're going to add an enum attribute to let us choose which control it is. So we'll modify, add attribute, and our attribute name is going to be called L leg state. Just like we have L arm state, now it'll be L leg state. We'll choose enum. First option is going to be FK. Second option will be IK. OK. Now what we'll do is use the same blend control that we used on the arms to tell the leg which one's controlling it, either the FK leg or the IK leg. So we want to use that blend tool that's up in the shelf here, right there, and we'll bring that up. Now remember, object 1 is going to be the FK joint, object 2 will be the IK joint, the target is the up leg, then the attribute that we're going to be using is rotate. The driver will be settings underscore anim dot L leg state, and we'll click go. Now if you remember correctly, what that does is that allows us to choose if we're going to have the FK control the leg or the IK, and settings anim here determines which one it is. So it's IK, that's FK. So right now that's just for the upper leg. So what we want to do is now do the low leg. So we'll go back up to object 1 and we'll change this to LFK low leg joint. Object 2, low leg joint. And the target object is low leg joint. Attribute is still going to be rotate. We'll click go. So now the lower leg is involved in this as well. And we also need to change the attribute name to translate because we're going to be allowing the leg to stretch, just like we did on the arm. So we'll switch the attribute to translate, click go, and that's going to hook that up. And now we want to hook up the foot. So we've got the FK foot joint, the LIK foot joint, L foot joint. Set the attribute to rotate, click go, and then again set the attribute to translate, go, and then finally we need to add the toe. So toe, 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 set this to rotate, click go, and there we have it. Now the up leg, or the actual leg control, is driven by either FK or IK. If we're in FK mode, we can just sit here and rotate like that, and it works fine. If we go back to settings anim, we switch over to IK, and the IK control will drive it. So there we go. Undo all that back, and let's go ahead and save this as Foot Rig version 2. File, save scene as version 2. The next step is to create the FK controls for the FK leg, just like we did for the arms. We want to make sure we've got curves that work for us just how the arms do, but this time just for the legs themselves. So in order to do that, we create a NURBS circle under Create NURBS Primitives Circle, like so. We're going to rotate the circle a little bit so it is oriented correctly. In this case, we're just going to rotate it down about 90 degrees in X. And then choose Modify Freeze Transforms. Bring up the option box and make sure that everything is selected. There we go. And then what we'll do is we'll add the curve as a shape to the LFK up leg joint. So we select the NURBS circle 1, select LFK up leg joint, and then in our channel box, or in our shelf over here, we find the shape button, click that, and that will add the circle right there for us. Okay? So now we want to modify the CVs so we can actually make the circle look like how we want. So we go back here to the CV tool, select the CVs, and then we'll just scale them down and move them appropriately so they line up how we want for the actual leg. So scale, maybe bigger this way, smaller like that. Basically, you just keep doing this until you get a rough shape for what you want for the leg. So I think something like that will work just fine. And now we want to continue doing this for the lower leg. So select the circle, and remember we have to duplicate this. We'll delete that original one and use the duplicate for the lower leg. So select the NURBS circle 2 LFK low leg joint, click the shape button, go into component mode, select those CVs, and then manipulate them so that they look how you want for the lower leg. Like that. And again, you can use any shape you want. I'm just using circles because it's easier to work with. But if you have something specific you like, go for it. You're more than welcome to use it. And now we'll do the same thing for the foot. So we'll select NURBS circle 2, move it out of the way, duplicate it, delete NURBS circle 2, and take NURBS circle 3, select the LFK foot, click the shape button again, and again modify those CVs so they're how you want. So maybe bring that over, bring it down, select the CV, pull it back. Maybe this one, we'll pull that up a little bit, pull this back over, make it so we can select it from behind. Because again, the whole point of this is creating a curve that's easy for the animator to work with and select. Okay? So we've got the curve for the foot, and then we want to do the same thing for the toe. So finally, NURBS circle 3, duplicate it, delete NURBS circle 3, select NURBS circle 4, click on the LFK toe joint, click on shape, and then go ahead and tweak this one until you get the shape that you want. And we just keep going through until it looks how we expect. Let's flatten this one out a little bit there. Alright, and delete NURBS circle 4. Now we've got the FK controls that when you pick them, you can move that FK joint and move it around. Finally, as you hopefully know by now, we want to make sure that everything is named correctly because that is going to be one of our goals. So we want to make sure that all of the controls have the proper underscore of anim instead of FK up leg joint. We want it to be FK up leg anim. So we select each of those joints that we're going to be using for animation, and we go here to the Add Suffix button, which is this one. Click on that, scroll down till you find anim, add suffix, and that'll replace it. So everything is now got the anim at the end of it there. Okay. And finally, what we want to do is make it so that each of the FK legs can scale properly. And to do that, we're going to use the same length control that we have on the upper arm here, where we've got that length attribute. So, again, remember how to do that? Where you select the upper leg there, and then we go over to our shelf, and there's a button here called SDK length. So I'm going to attach the length to the joints. So when the prompt appears, we choose translate because we want to make sure that everything translates correctly. So click translate. We want to scale any child geometry? No, because there is no child geometry. Select the lower leg, length, translate, no, foot, and toe we're not doing length on, so we don't worry about them. We just have the upper leg, which will scale out, and the lower leg length. Whoop, and scale that. So let's go ahead and save this, and we'll save it as file, save scene as, foot rig version 3. And we've got our basic FK leg rig set up and running. That was pretty quick. It's one of the great things that happens when you've tested stuff out and you've got a rig starting to work and you know that you want things to be consistent, is we know that our FK foot rig and leg rig should be working very similar to our FK hand rig. So let's go ahead and move on to creating the IK now. Now as we start to work with the IK legs, let's make sure that it's easy for us to work with by, first of all, hiding the FK legs so we don't have to look at them. And then let's take a look at the regular leg that's being used here. And we're going to put that in the Do Not Touch layer so we don't have to worry about accidentally selecting it. So simply select L up leg joint and do right mouse button, add selected objects over the Do Not Touch layer. And now when we click and drag, we're only going to be selecting the IK leg control. This is going to make it easier for us to work with. We're also going to go ahead and set our current settings anim for the leg state to be IK, which means that we can actually see how this is affecting the leg itself. And we can start creating the leg. So let's go ahead and create an IK chain. So go skeleton, IK handle tool, and bring up an option box. And we want to make sure that the current solver is IKSC solver, which it is. Great. And what we want to do is create an IK chain now that goes from LIK up leg to LIK foot joint. So we'll do that. Then we'll create one from the foot joint to the toe joint, and then create one from the toe joint to the toe end joint. This should all seem very familiar considering this is what we just did on our test leg. And we'll rename this. So L_leg IK handle, L_foot IK handle, and L_toe IK handle. So now what we want to do is create a foot control just as we did before for testing out our ideas. We want to do this on JJ himself. But let's go ahead and hide some things that we don't need to see so everything is less cluttered. So we'll hide all anim. And let's go ahead and change to a top view so we can create a good foot control for us. Because remember, we want our foot control to be similar to all of our other controls, which means created from a NURBS curve. So we'll go to Create, EP Curve Tool, and go to the option box. In here, we're going to make sure that the EP curve degree is set to linear. And then we'll just create a foot control that goes around our foot. Something like that to there, to there, to say here, here, there, and then all the way back to, that went up too high, there. Alright, so now we've got our little foot control. Yay! Let's go ahead and rename it. And we're going to call this L foot anim. Now if you notice when we try and work with this foot, the pivot is over here at the origin. So what we want to do is move the pivot actually to where the heel is on the foot. So best way to do that, select this foot joint, then add to your selection of the foot control. Then we'll go over to our shelf, click copy, and that'll move the pivot over so it's lined up correctly with the foot. Alright, so now what we need to do is start creating some pivot locators for the foot rolling, the side to side, and other things. First, let's go ahead and create the heel pivot. So we'll go create, locator. We're going to rename this to heel loc, just like we did before, and we're going to put it on the heel itself. So if I switch to my move tool and go to point snap, boink, right there, exactly on the heel of the character, just where we want it to be. Okay, now we're going to create a ball locator, and I'm just going to duplicate heel loc and call this ball loc like that, and we'll move this so it's on the ball joint right there. And we're going to create a toe pivot, so we'll duplicate the ball locator again, and we're going to rename this to be toe loc, and we're going to put it on the toe itself, right over here. Next, we go ahead and parent the locators and IK handles and stuff the way we did when testing the foot rig earlier. So, first thing we're going to do is parent heel locator to L foot anim, poop, like that. Then we're going to parent the toe locator to the heel locator, and we'll parent the ball locator to toe loc, like so. Then, I realized I misspelled toe there, so it's just toe IK handle. Take the leg IK handle, parent that to the ball, and then the foot and the toe IK handles and parent those to the toe locator, like so. So now we've got the foot control, which will move that around. We've got the heel locator, which will pull the foot back. We've got the toe locator, which will lift up like that, and the ball locator, which will do that. So what we also want to do is add some side-to-side locators to give us the same ability that we have on the hand, where we can lift it up from the side to side. So let's create a new locator, like that, and we'll move it over to the inside of the foot. And we're just going to line it up with the geometry, so right around over here, like so, and we'll call this inside loc, like that. Then we're going to duplicate that and move it over to the outside of the foot, like over here. And we'll call this outside loc. Now what we want to do is place the outside and inside locators within the hierarchy of the foot so they move with it. So we'll take both of these, we're going to parent them to heel locator, so it moves with the heel. And we're going to take the inside locator and parent that to the outside locator, like so. Then we'll take toe locator and parent that to the inside locator. So let's see how all these things work out. It's pretty crazy. There's locators everywhere, but it'll all start to make sense. First of all, we have the heel locator, which will move the entire foot back on its heel. We have the ball locator, which will lift up the ball of the foot. And the toe locator, which will lift up the toe, like that. In addition, we've got this inside locator, where if we take the rotate Z, we can lift the foot that way, and an outside locator, which will lift the foot that way. So we can do things like take the ball of the foot, lift it up, and then grab the inside locator and go like that in order to get the foot up on its side, which is really, really powerful. And now that we have all of our locators set up, let's go ahead and add all the attributes we're going to need on the foot control itself so that it's easy for the animator to use. So we'll select L foot anim, click on Add Adder, and let's add our attributes. We need roll, toe lift, toe straight, lean, and side. And those are the 5 that we're going to use. Okay? Boink. Like that. You notice that there is a new attribute in here called lean. This will be used to just add a little bit of extra control on the foot for leaning it side to side without actually lifting the foot. So, for example, when we take the ball and we go like this, and we use inside locator, go like that, it lifts the entire foot. But what we can do with lean is actually just lean the foot this way and this way, which will allow us to get a little bit more subtle control, which will be really useful. Okay, let's go ahead and create the expression to deal with the foot. So we'll go Window, Animation Editors, Expression Editor. And our expression is going to look like this. First we want to grab the roll value. So roll is equal to L foot anim.roll. We want the toe lift. So toe lift is going to be equal to L underscore foot anim.toe lift. We need toe straight, which is going to be equal to L foot anim toe straight. We need lean, which is L foot anim lean. And we need side, L foot anim side create. And we will call this L foot expr, like that. Now we'll add the expressions, the lines of expression that actually cause things to happen. So let's first affect the heel locator. Heel loc.rotate x is going to be equal to, remember this from before, min roll 0. Like that. So as we take foot anim, we drag it back and forth, our heel is being affected. Now we want to add the ball locator. So ball loc rx, remember this one, lin step 0 to toe lift to roll times 1 minus lin step toe lift toe straight roll times roll. And I have an expression error in here somewhere, so ball loc rotate x equal to, let's see what the error is. I probably forgot something. Aha. There we go. Need that extra % in there. Click edit. Cool. And now what that will do, if we take toe lift, we set that to 45, toe straight to 90, and then we take roll. See how that goes like that? So roll is going up and then down, up and then down. That's what we want. But now we got to lift up the toe on the ball of the foot. Okay. So we come in here, and now we add toe loc rx is equal to lin step toe lift toe straight roll times roll. And now what the roll does is whoop, lift the ball up and goes back to heel. Next we're going to add the lean ability so that we can actually lean the foot side to side without lifting it up. To do that we're going to add this one. Ball locator dot rotate z is going to be equal to lean. So if we have ball up like that and then we choose lean, we can now lean the foot side to side. Like that. And then finally we want to work with the side to side control. So we'll choose outside loc.rotate z is going to be equal to min side 0. This is going to be just like the heel and ball control. Inside loc rz is equal to max side 0. Okay, so let's check out the side to side. Boop, boop. There we go. So we've got roll. We've got the toe lift controls, which we can control where that actually happens. We've got the lean. and we've got side to side to lift it up like that. So far it's looking pretty cool. But there's something else we want to do. We also want to add the ability the ability to pivot the entire foot around the toe. This comes in handy when a character needs to just push their heel over a bit, and it really is useful for adding a sense of weight and urgency to a character's movement. In order for it to move right, though, we need to make sure the toe's rotation orders are correct. And since we're going to be using the Y value on the toe to twist it, we need to make sure that that is the first rotation order. And right now, it's not. So if we bring up the expression editor and go to the toe, we can switch the rotation order to ZXY. So now we're going to add an attribute called toe spin, like that, which shows up there in the channel box. And we're going to modify our expression again. So we're going to add the toe spin attribute here. So spin is equal to L foot anim dot toe spin. And then down at the very bottom, we'll choose toe loc dot ry is equal to spin. Edit that. And now we can take the entire toe and spin it out this way. So our foot control is almost set up correctly, but there's something that's actually missing. As we animate and move this thing around, we can grab this, we can rotate it, we can do all sorts of things, but the one thing we can't do is actually bend the toe down or up. And this is really important. You need to be able to add that little bit of extra motion to the toe to allow the character to flop around, make the feet look a little bit wobbly and stuff like that. So to do that, we're going to go to the ball locator, and we want to be able to bend around that joint. So we'll duplicate ball loc, and we're going to rename this to toe wiggle locator. We'll delete the children of toe wiggle locator there. And we're going to parent the toe IK handle to toe wiggle loc, so that when we take toe wiggle now, we can go and wiggle the toe. Okay? But we need to hook that up to the foot. So we'll go back to our foot anim, click on add attribute, and we'll call this toe wiggle. So that shows up there inside the toe wiggle. We'll go back to our expression editor, and then in here we'll say wiggle is equal to L foot anim dot toe wiggle, and down at the very bottom we'll say toe wiggle loc dot rx is equal to wiggle. So now we can use toe wiggle to wiggle the toe. We've got toe spin, we've got side, we've got roll, we've got everything we need to make a really good, nice foot walk. Before we save, let's go ahead and just clean things up a tiny bit. We're going to hide the locators because we don't need to see that mess. So we'll select heel locator and hit Control H. Before we save it, let's just check and make sure that everything does exactly what we want. So we've got the foot, we've got the roll attribute here, which will roll backwards and forwards, which it works exactly how we expect it to. We can take the toe lift and change that to something like 35, and the toe straight, maybe set that to like 70. And now as we roll, the toe will be straight by the time we get to 70. This is pretty good. That works very well. We can use the lean to lean the foot side to side. We can use side to go up on the side of the foot. We can use toe spin to spin the character's foot around. And we also have toe wiggle to wiggle it. So far things are working pretty well. So far this looks pretty good, but what happens if we combine side and toe spin? Let's check that out. So if we use side, and we go over like this, and then we use toe spin, watch what happens. Notice how the foot goes into the ground. That's not very good. We want to be able to spin the foot without it going through the ground surface. So what do we need to do? First we need to try and understand why it's happening. If we look at the hierarchy of the foot, you can see that the toe locator itself is a child of the inside and outside locator, which means it's going to inherit any of the motion that comes from those two locators. If the locator is rotated so the foot's on its side, then toe loc is going to do the wrong thing. So we have to reorder the locators so that toe loc is above and the outside and inside locator. It's really important to test your controls to make sure that this type of thing doesn't happen. So what we're going to do is parent toe locator underneath heel loc, like that. And then we're going to parent outside locator underneath toe locator. And then we'll take the ball locator, the L foot IK handle, and the toe wiggle locator and parent those underneath inside locator. So now, if we take side and we bring that up, and then we do toe spin, it will spin correctly. So again, very important to check these things out and make sure that the foot interacts and all your controls interact the way you want, not just on an individual control basis, but when they're actually interacting together. Let's go ahead and save this current version. File, save, scene as. Choose FootRig version 4. Now that our leg is roughly set up, we need to add the ability to lock the knee to the ground and to also have a non-flip leg. If we were simply creating the non-flip leg like we did in the test, we could use the same technique we were using earlier. Just switch the IK over to pole vector and put on a pole vector constraint and we'd be done. Unfortunately, we do need to be able to lock the knee down. In order to lock it, we need to come up with a different system, one where the pole vector follows the knee explicitly and allows us to turn on stretch. But the problem is it's such a limited case when this happens. You don't really want to make the animator have to worry about the knee's location. So what we want to do is come up with two specific leg solutions. One that the animator will use when they're locking the knee down, and one that they'll use normally, which is the non-flip leg. Luckily, we can create these two different leg IK setups and let those drive the current IK leg, and then let the animator pick which one they want at any given moment. So here's what we're going to end up with. We're going to have a no-flip leg IK structure, a stretchy IK leg structure that we can lock the knee down. That will drive our IK leg, and then the IK leg and the FK leg will blend together to get the result leg. And this will allow the animator to use no-flip usually, stretchy IK sometimes, and FK sometimes. Okay? So let's go ahead and start creating these two different leg structures. What we're going to do is create two options for the IK leg, but only from the up leg to the foot. The whole foot structure itself will stay the same, so we don't have to worry about duplicating any of that. We'll basically just take from the up leg to the foot, and we'll have a no-flip leg and a pole vector leg, and both of those will be driven by the foot controls. So for the animator, it's going to seem pretty seamless. They'll only know that they're moving the leg and deciding how the knee is controlled, either by no flip or by explicit knee position. But we'll know that there are actually two IK structures driving the resulting leg that in turn drives the resulting geometry. Okay? Let's go ahead and create the two extra legs. So in order to create the two legs, we're going to use the grep rename button again to make it easier. So first let's create the no flip IK leg. We're going to select the LIK up leg joint, and then in our shelf we'll click on the grep rename button. Now for the text we search for, we're going to enter IK, and we're going to replace this with no flip, like that. Then we're going to choose duplicate, and click go. That's going to duplicate the leg for us, and we'll have now no flip, up leg, low leg, etc. And as I said earlier, we're going to be using only the up leg, low leg, and foot, so we don't need the toe or end joints, so we can just go ahead and delete those, like that. Then we're going to go ahead and create the pole vector joint structure. So we'll select the L no flip up leg joint. We're going to click on the grep rename button again to bring up our interface, and we're going to search for no flip, and we'll replace this with PV for pole vector. Make sure duplicate rename is on, hit go, and now we've got our LPV up leg joint and our no flip up leg joint. So now that we have these two structures, we can get rid of the old animation, the old IK that we have from up leg to low leg to IK foot, and we'll just drive this with a blend between these two, just like we're doing with the forward kinematic arm and with the FK to IK leg. So as you can see, we've got our no flip and our pole vector leg driving the inverse kinematic leg with a blend, and then the inverse kinematic leg and the forward kinematic leg driving the result with a blend. So you can see these kind of layered approaches to rigging this. So the first thing we'll do is we'll delete the L leg IK handle. So if we open up ball loc, L leg IK handle, we'll get rid of that. Boom! Now let's add an option for the animator to decide whether they're going to be using the pole vector leg or the no flip leg. But instead of calling it pole vector or no flip, we'll name the attribute something that makes more sense. If you think about it, when they're in pole vector mode, they can see the knee locator, and then when they're in no flip mode, they can't. So we'll create an attribute that just tells them whether or not the knee is visible, and that way they know what type of solution they're going for. It's really important to name your attributes like this in ways that make sense for the animator. Don't just call it the matrix visibility Fortran gobbledygook or whatever. Name it whatever it makes sense for. So we'll select settings anim, and then we're going to go to modify, add attribute, right there. And we'll come up with a name for this. Say something like L leg knee viz, and we'll make it a boolean. So yes, it's either on or it's off. Click OK. Then we'll go ahead and create the blend. So we'll go here to our blend tool, and the object 1 is going to be when the leg is off. So when the knee visibility is off, that means we're going to be using the no flip leg. So we'll choose that. When knee visibility is on, we want the flip leg, or the pole vector leg, the flip leg. And then for our target object, it's going to be the LIK up leg joint. The attribute we're going to use is rotate, and the driver is going to be settings anim L_leg knee viz. Just that's the attribute that we just created. We'll click go, and now we can use that to control which leg is going to drive the IK there. We'll do the same thing for the lower leg. So change this to no flip low leg. We'll change this one to low leg. Change this one to low leg. And we're choosing our attribute of rotate. Click go. And now we want to make sure that the translate is going to work as well, so we'll change our translate here, or our attribute here to translate. Go. Finally, we want to work with the foot as well, but we don't need to worry about the rotation because that's being controlled by the IK handle. All we need is the translation so we can get the length of the entire leg. So leave translate there and click go. So now either the no flip leg will drive it or the pole vector leg will drive it, depending on what they have set in their settings. Alright, so we've got the blend working between the two IK leg options, but now we just have to create the IK. So let's start with the no flip leg. Unfortunately, it's not as simple as just creating IK like we did in the toolkit. We want the leg to be able to stretch when the foot travels too far away. So we have to use the stretchy IK button that we used when we were working on the arms to create the IK that stretches, and then make sure it works with the all anim global scale attribute as well, so we can scale the entire rig. Remember, we got to make sure that we're thinking about these things as we're creating this stuff. So we'll select the no flip up leg joint and the no flip foot joint. We'll go up here to our shelf and we'll click on the create stretchy IK button, like that. Set the IK solver to RP. Set the scale method to translation, which it is. The world scale object is going to be all_anim, and then the world scale attribute is going to be global scale. Apply. So our new leg is created. Let's go ahead and rename the knee because right now, when this gets created, it calls things, no flip up leg joint, L no flip low leg, blah blah blah. So what we'll do is select the knee control, which is this one, and we're going to call this L no flip knee, like that. Now we want to move the knee off to the side. Notice how as I move it, it moves and rotates that. Make sure I've got my grid visible. And what we want to do is position it down by the foot, but move it off to the side a bit over there. So we'll move it, say, about this far over here. Now we need to fix the orientation here, so we'll go to our IK handle, and we're going to change the twist to a value of -90, which should point the knee in the right direction, which it does. So now we're going to parent the knee and the end control to the foot rig. This will make sure that the IK works correctly and that the knee travels along with the foot. So we'll select the L no flip up leg joint distance end and L no flip knee, and we'll go to ball loc and we'll parent them like so. So that now when we take the foot and we roll it, it works correctly. Like that, and it works like this. And that's because we're in no flip knee land. So remember though, we need to add a control to actually spin the knee. So what we want to do is group the no flip knee itself and make sure it's going around the end of the control there and allow it to spin around there. So to do that, we're just going to go ahead and duplicate the no flip uh, the up leg joint distance end, because that's going to be parented directly at where the ankle is. We'll delete the child, and we're going to call this to L no flip knee group, and we're going to parent the no flip knee to the knee group like that. And then what we need to do is add the spin control to the foot anim. So we go over here, click on Add Adder, and we're going to call this knee spin. And now we can hook the knee spin up to the foot control, or to that knee spin, or that knee group itself. You can either use a direct connection or the expression editor. I'm going to use the expression editor just because we've already got it open and it's simple to use. So we're going to call this knee spin. It's going to be equal to L foot anim knee spin, like that. And then we'll say L no flip knee group RY is equal to knee spin, like that. So now we can take the foot, we can move it, we come over here to knee spin, and we can spin the knee around as much as we want. Alright, so right now we can go ahead and stretch the legs out and move them around, and we've got all sorts of great controls on our leg control itself. But what happens if, when we're in FK mode, we use the length attribute on the legs and we do it so it's not uniform? So the upper leg is twice as long as the lower leg, which is totally possible. At some point, the animator is going to want to switch between the FK and the IK, and we need to make sure that our IK leg can do almost everything that the FK leg can do in order for it to switch correctly. So what we need to do is actually add individual length controls to the upper and lower legs. If we don't do this, we can't make sure that they can switch back and forth between FK and IK very easily. Okay, so in order to do that, we're going to add a length attribute for the upper and lower legs. So with L foot anim selected, we're going to choose Modify, Add Attribute. And we're going to name this up leg length, like that. We want the data type to be a float. We want the minimum to be 0 and the default to be 1. There is no maximum here. And we'll click Add. Then we're going to create an attribute called low leg length. It would be helpful if I actually typed it in the attribute name itself instead of down a minimum. Low leg length, a minimum of 0, default of 1. Add. Alright, so we've got the up leg length and the low leg length. So in order to actually hook up these attributes, what we want to do is use them as multipliers to the leg translation, because we're already using the translate x attribute to drive the scale of the legs based off of when the foot is moving. So if I go like this, I need to be able to increase the length of the leg more if I want to. So I can't just do a direct connection to the translate x. I've got to add it to this. So remember, if we look at how our legs are being figured out for the translation, we've got the distance measured between the hip and foot, and then we're doing a whole bunch of clever math to deal with the world scale and all sorts of other stuff to give us the low leg length and the foot, or the low leg translate x and the foot translate x. So what we want to do is insert a multiply and divide node between all the clever math that we've got going on the legs and the translate x to allow the legs to scale, but we want to make sure they keep working with the rest of the system. So it's really important that we incorporate the low leg and up leg scale so it works with everything else and doesn't break. So how do we do that? Well, let's go ahead and select the no flip low leg joint, and we're going to bring up the hypergraph by going Window, hypergraph connections. So here you can see this is the low leg translate X. We've got this blend coming in here from the joint, which is getting the world scale over there, and then it's measuring the distance between where the knee is and where the world position is, and doing all this stuff so that we can actually stretch the knee correctly. Okay, so what we want to do now is create our multiply divide node in order to insert that. So we'll go to rendering, create render node. We'll go over to the utilities tab and we'll click multiply divide. And as you can see, that's placed that over here. So we'll grab this and drag it over. Let's rename this so it makes a little bit more sense. We're going to call it no flip length mult, like that. And what we want to do is select the left foot anim in the outliner and drag that into the hypergraph as well, because we're going to be using those attributes. So bring that in. There those two are. Bring them back over. Okay, so this elbow blend here is the input that's going into the joint. And if you remember from our diagram here, we have all sorts of stuff happening before it, and then it goes straight into the low leg translate X. That's where we're putting our multiply divide node. So that's where we want to put our multiply divide node here. We want to take this and redirect it into there. So I'll just drag that directly on, choose other, and now you can see that we've got the attribute blender, which is right there. That's what's being driven. So if we look over here, we've got the output going into the translate X. So we'll go back here, turn on show non-keyable, take the output, and we're going to put that into the input 1X. So it's going boom into here as well. Okay? Then we're going to take the L foot anim and we're going to drag that onto the no flip. Bring up other. And if we scroll down, we've got the up leg length. We're going to take that and we're going to connect that into the input 2X, like that. So the up leg anim, or the up leg length, is now going into this no flip length multiplier. The low leg joint elbow blend is going into that. And then we're going to take the no flip length and put that onto the leg. Boop. Like here. And we'll take the output X and we'll drive that onto the translate X. Like so. And then we close that. Alright, so now if we were to take a look at the L foot anim, and we're going to do the up leg length, you can see that as I drag that, it's going to affect the upper leg length. But selecting this and moving it still works as we expect. But we need to do the same thing for the lower leg. Okay, so we bring this back up. We've got our low leg joint right here. Our no flip length multiply divide node. And what we want to do is grab the no flip foot joint and drag that in here now as well. So we can use this too. So we've got the no flip foot joint. We've got the no flip foot elbow bend. We've got the multiply divide node here. So if we take this no flip foot joint elbow blend, same thing that we have on the other one, and we drag that onto this length multiply node, bring up other, we're going to connect the output to the 1Y, like so. And now we want to take the thing for the foot control itself, the foot anim, and we'll take this one and put that into the multiply divide again. But we'll say that this time it's the low leg length is driving the input 2Y. There. And then we'll do just what we did on the low leg. We'll come here and we'll say the output Y is going to drive the translate X. So now we've got the up leg length and the low leg length, and they can be affecting everything, and it can still work with our regular control that we have normally in there. Cool, right? Okay. Let's go ahead and save this version. File, save scene as. Foot rig version 5. Alright, so we've got our no flip leg working. We can spin the knee, we can move the leg, we can roll the foot, we can scale each of the individual legs so that they can match up with the FK, and it's time to go in and set up the pole vector. Before setting up the pole vector leg, we should go ahead and turn on the knee visibility since that's the mode we're about to be in. So we'll go over to the settings anim and set knee vis to on. Now you'll notice that the other leg, the pole vector up leg, controls the resulting leg. The knee control itself that we're going to use will look like a locator, but will still be made with curves. That way the animator can hide the curve easily, and we're being consistent with the rest of the rig. Let's go ahead and import the knee control. Going File, Import, into Example Files, and choose curveloc.ma. You'll see here's the curve locator. We'll go ahead and just move this right up around over here, and you can see it looks just like a locator, except it's made of curves. So now what we want to do is position it. First we need to rename it. So we'll rename it to L knee anim, so it's named the right thing. And then we're going to put it in front of the knee so the knee's aiming in the correct place. We should also scale it as well so it's not as distracting. So we'll scale it down so it's about that size. We're going to position it so it lines up with the knee itself. Make sure that's right where the knee is. And then we'll just pull it out a little bit like that. Let's go ahead and freeze the transformations. Modify, freeze transforms. But we're not going to turn on translate because we want to make sure that it's in the correct space in world space. But we want to freeze, rotate, and scale like that. Now we're going to create IK for the pole vector leg the same way we did for the non-flip leg, where we select the pole vector up leg, pole vector foot joint, but then we're also going to select L knee anim. And then we'll click on the stretchy spline. We're going to choose an IKRP solver. Scale method is translation. World scale object, again, will be all_anim. And global scale will be the global scale control. Now what we want to do is parent the end control so it works with the rig, just like we did before. So we're going to parent that to the ball locator. So we select LPV up leg joint distance end. Parent that to the ball locator, like so. So if we select this guy and move it, the foot moves correctly, and stretches out and everything like that. We can hide the L knee anim locator, which is this one. Because that locator is automatically created, we don't need to see it. Here we've got L knee anim. Notice it's got the stretch control. We can turn that on. This is the same thing that we have on the arm. And when we move it, the knee will follow and aim for it, which is great. Now, we don't want the knee to be visible when the animator isn't in pole vector mode, so we're going to connect the visibility of the knee to the settings. So we'll go to Window, General Editors, Connection Editor, click on Reload Right, and then we'll go up over here to our Settings anim, choose Reload Left. The L knee vis will be connected to the visibility. So right now, because we are in knee mode, where we can see the visibility, we see it. Set that off, we don't see it anymore. You'll notice that the L knee anim control isn't actually parented to anything. This is because when we're in this mode, we're going to assume, or if the animator's in this mode, we're going to assume that they want to lock the knee off, or they want to be able to parent it to something or constrain it somehow. Otherwise, they'd be using the spin control. So we're going to leave that out in the same space as the foot. So let's go ahead and save this version. File, save scene as, and we'll choose foot rig version 6. Alright, so we've got all of our controls set up for the leg, but it's all pretty messy. But we can use IK, we can use FK, we can stretch the knee, we can stretch the FK controls, we can stretch the IK controls. Let's go ahead and look at our different animation rules and make sure that everything is working the way we expect. Remember our rules. We need simple controls. The animation needs to be easily transferable so we can copy the animation from one rig to another. The controls should be unique and understandable. They should have the correct rotation orders, named correctly, and have limited keyability. So let's look at this for the FK control. So first let's go ahead and turn on the visibility for the FK leg so we can take a look at it. If we go back up here to settings anim, set the FK state to on, we're in FK mode, and let's make sure our FK is visible. There we go. Alright, so with our FK controls, they work as expected, and they are the same as all of our other FK systems. So we know exactly what they look like, and we know how they work. With the IK controls, we have two different ways of manipulating the IK leg. One that uses the spin attribute on the foot control, and the other uses the knee pole vector control. The rest of the IKs are on the foot, and while the roll attribute might take a bit of time for the animator to get used to, you can either use a different roll system, or you can use this one. Doesn't matter. But either way, it's relatively simple to work with. Whether or not it's the best solution is up for you and the animators to decide. But overall, I'd say that we pretty much have simple controls that are easy to understand. Animation easily being transferable. All of our controls are made with separation from the actual joints or geometry, so the animation can be transferred and copied easily. Controls are unique and make immediate sense. Well, all the controls are NURBS curved and are unique for what they're achieving, so we definitely have that. Correct rotation orders. Let's go ahead and step through the controls and make sure our rotation orders are correct. The FK controls themselves are all pretty much the default rotation, but they seem to work pretty well for what we need. So I would say yes, the FK controls definitely have the correct rotation orders. The knee control doesn't need any rotation, so we can ignore that one. The foot itself needs to have the correct rotation order, I think, because right now, as you can see, rotating it in Y doesn't do the correct thing. So we should change this rotation order here from XYZ to ZXY or XZY. It doesn't matter which one, or it's up to you to figure out which one. So let's try and figure it out. If you imagine the foot's going to be doing most of the time, you can figure out what's most important. For example, the foot will be orienting around Y to face the right direction most of the time, which will be doing that. Then it'll probably be going up and down because it's going to be walking and moving and stuff like that. So moving up and down will probably be the next important. And then side to side will probably be last for twisting. So based on that, what we probably need is ZXY, where Y is the most important, then comes then comes X, and then comes Z. So ZXY is the rotation order that we want to have for the leg. Controls should be named correctly. So let's look at the controls piece by piece and make sure they're named how we want. Since we're in IK mode, here, let's put ourselves in IK mode so we can start with that. IK. So what have we got? We've got L foot anim, which is correct, and L knee anim. Both of those make sense. So let's take a look at the FK controls. We have L FK up leg anim, L FK low leg anim, L FK foot anim, L FK toe anim. Those are named correctly. So it looks like everything is named exactly how we want. And finally, limited keyability. We have to make sure that the animator can key only what they want. Well, finally it looks like we're going to have to do a bunch of work because there's things here that the animators are able to key that they shouldn't need to be able to key. So let's go ahead and fix that stuff. So first thing, let's make sure that we set the visibility of the objects correctly based off of what we have what mode we're in. What we're in right now is FK, but we can still select all the IK stuff. So we need to make sure that our IK controls aren't visible when we're in FK, and our FK controls aren't visible when we're in IK. But what about the settings visibility that we did on the arm? We want to make sure that that works as well. So we need to add the ability to override any visibility setting for the leg, just like we did for the arm earlier. So to do that, first let's set up all of our visibility attributes. So we'll do modify, add attribute, and we're going to choose LFK leg vis, set that to boolean, add that. We want LIK foot viz, set that to boolean, and lik knee viz, set that to boolean. It's easy when there's only a couple of controls to work with. Now let's go ahead and group all of our IK controls together to make this a bit easier to see. So we've got the foot anim and the knee anim. We'll group those, and we'll call this L leg IK group. Now, since we're going to be driving the visibility of the knee with an expression using the settings, visibility, and the mode the foot's in, we'll need to break the connection that we made earlier on it. So let's go ahead and grab the knee anim, go to visibility, choose right mouse button, break connections. Now we're going to create an expression to drive all the visibility options just like we did on the arm. This will allow us to use the overrides to ensure that the animator is able to toggle on the visibility of the things they want to be visible, regardless of whatever mode they happen to be in. So let's create that leg visibility expression, going Window, Animation Editors, Expression Editor. Okay, and now what we're going to do is create a new expression. We're going to first get the mode that we're currently in. And we're going to say mode is equal to settings underscore anim L leg state, and the knee is going to be equal to settings underscore anim L leg knee viz. We'll create that. We'll change the name of this expression so it's L leg viz expression, like that. Go back to our select filter. There we go, L leg viz expression. Okay, now what we want to do, we've gotten the mode, so we know what mode we're in. We need to get the settings. And that's what's set on the, right up over here, settings visibility tab. So we'll choose L FK leg viz. It's going to be equal to settings visibility.L FK leg viz. Then the next one will be L IK leg or IK foot viz is equal to settings visibility L IK foot viz, and then L IK knee viz is equal to settings visibility L IK knee viz. Edit. Alright, so we're grabbing all of these different values. That part of the expression is used to get the settings and put them in variables. Now we're going to use the variables to modify the visibility of the individual items as we see fit. So first, let's look at the foot anim. L foot anim visibility. It's going to be equal to whatever mode we're in plus LIK foot viz. So what that means is we're going to look at the mode for settings anim. If we are in FK mode, that value is 0. If we're in IK mode, the value is 1. So we'll look at the mode, and then we're going to add the LIK foot viz right here, which is the setting for that. So if that's off, doesn't matter. If the mode is 0, it's off. If the mode is 1, it's still on. If the mode is 0, if we're in FK mode, and this is on, or this is off, it's going to be off. But if it's on, then it'll be 0 plus 1, which means it's going to be on. So we'll be able to see it. Let's do the knee. L knee anim visibility is equal to mode times knee, because what we want to do is figure out what mode we're in, right? So if we are in FK mode, this is going to be 0, so it doesn't matter what the knee visibility is here. We're basically in FK mode, so we shouldn't need to see it. If we're in IK mode, it matters whether or not we are in visibility, whether or not we're in knee visibility on or off. If knee visibility is off, we still don't want to see it no matter what. If knee visibility is on, then we should have a value of 1. So that's how we do that one. Then we're going to add L IK knee viz. So whatever mode we're in, if it's 0, if it's 1, it doesn't matter. We're always going to be adding the knee visibility, so if that is on, then we will always see this no matter what mode we're in. Then LFK up leg anim visibility is equal to 1 minus mode plus LFK leg vis. So if we're in FK mode, mode is 0, but we need the visibility to be on for that. So we do 1 minus 0, that's going to give us 1. If we're in IK mode, mode is 1, so we want it to be off, so that means 1 minus 1 is 0, so that's off. And then again, we add the visibility option there. Edit. Alrighty, so now, if we look at what mode we're in, we are in FK mode, and all we see are the FK controls. Switch to IK mode, we see the IK controls. If I set the knee visibility off, we don't see it. If I go back to FK, we're in FK mode. Let's check out our visibility options. So we're in FK, but I can turn on the foot visibility by turning that on there, turning it off. Knee visibility on, off. Let's switch over to IK mode. We go to our settings there, FK, turn that on, turn that off. We want to see the knee, we want the knee off. There we go. So our settings are working correctly now, and we can only select things for the mode that we happen to be in, which is great. Let's quickly save this version. File, save scene as, version 7. Alright, so now what happens if we click and drag over the leg? Notice we end up selecting the FK leg, the IK leg, and the other two IK legs. We don't want this to happen. And we also still see these locators here. What we really want is just to allow the animator to pick only the FK controls when we're in FK mode. So we need to hide a few things. Okay, so the first thing is, let's hide all the legs besides the FK leg, because when we are in IK mode, we don't need to see any of these legs. So we're going to select the LIK up leg, L no leg, or no flip leg, and the pole vector leg. We'll hide those. Then we're going to hide the locators. So the two start locators, we're just going to hide those because we don't need to see them anymore. Now we can set the attributes that are supposed to be keyable. Alright, so if we select the LFK up leg, let's highlight the translate because we don't want to key the translation, and the scale, we don't want to modify that. Choose right mouse button, lock and hide selected. Then we're going to choose the visibility and the radius, and we're just going to hide those because we don't want the animator to key them, but we don't want to lock those either. Now we'll go down to the lower leg. So we select that, choose the translate Y and Z, and the scale all the way down to visibility, and we will lock and hide that. Choose the translate X, the radius, and we will choose hide. On the foot, translate Y and Z, all of the scales and visibility, lock and hide. Translate X and radius, just hide. And on the toe, translate scale and visibility, lock and hide, radius, we'll just hide. Alright, so now the FK controls, we can only key the controls that we want the animator to be able to set keyframes on. Let's go ahead and save this version. File, save scene as, version 8. Let's go ahead and set the keyability for the foot controls. So we'll change our settings back into IK mode. Select the foot. And then we'll go in here and say, okay, we want translation, we want rotation. We don't need the scale. We don't need to worry about visibility, but we can't lock that because we're dealing with it for setting what's visible. So we'll lock and hide scale, then we'll go to visibility, and we'll just hide it. There we go. So that's all of our controls for the foot. Let's go ahead and set the knee visibility on for the knee control. And here we're only dealing with the translation. So rotation and scale, we'll go ahead and lock and hide. Visibility, we'll just hide. Let's go ahead and set the settings and I'm back to the default state, which will be in IK mode with the knee visibility turned off. And we will save that. File, save scene as, foot rig version 9. Alright, our rig is set up so the animator can only set keyframes on what we want them to set, which is great, but there's still a lot of cleanup left to do, and we have to actually attach the leg to the rest of the rig. So let's go through all of our rig requirements. First, we want to limit the control selection. Then we need the clean rig presentation, and we need the rig relocation program. So only allow the animators to select what we want. We've basically taken care of that when we're making sure the attributes were correct. So we don't need to worry about that. The clean rig presentation. We need to make sure we have a clean outliner. Let's take a look at what it currently looks like. Alright, if we look at our outliner, you can tell it's pretty messy. There's a whole bunch of stuff that we really need to clean up. So the first thing, let's go ahead and group everything together so that we have one clean group to work with for the leg. So select everything except for L leg geo. Control G to group that, and we're going to call this L leg group. Okay? So that's first things first. Let's open that up now. Okay, so under here, what we want to do is group all the controls together that we're going to be working with. So we'll get the L up leg joint group, the FK up leg, the IK legs, all those, the start controls, and we're going to group those and we'll call them L leg control group. Okay? Now we need to create a do not touch group, things that we don't want the animators to pick. So we'll grab all of these distance nodes, group them, or we're going to call them L leg do not touch group. So far this is looking quite a bit cleaner. Let's parent this group to all anim group because it's going to go underneath our animation controls, and we'll show everything. So there it is. We've got our leg group there along with everything else. Now we need to attach the legs to the body because as you can see, they're not. So in order to attach the legs, we're going to parent constrain the control group, which is this one, to the hips. Allow it so that it can basically move with the hips, but it's still separate so we can pull it apart if we need to and work with it. First thing we need to do is make sure the pivot for the control group is in the right spot. So we can do that by selecting the L up leg joint and then L control group, copying the pivot. So now the L control group pivot is up here, right where we need it to be. Then we're going to duplicate that L leg control group. We'll delete all the children of the duplicated object because we just want that transform itself. And we're going to call this L leg control constraint because it's going to be a constraint for the leg group or for the control group. So we'll select the constraint, then we'll select the L leg control group, and we'll go constrain parent like that, so that this constraint is the thing that drives it. Then what we want to do is parent this underneath hip anim. So we'll do that. So now L leg control constraint is underneath the hip anim, so we take the hip anim control and we move, and you can see that it's now affecting the leg correctly. Sweet! Just as we want. But notice something funky with the legs. When we pull things apart, see how the leg stretches but the geometry doesn't? It's not a huge problem to have this, but it's a little bit ugly for the animator. You want to make sure that the geometry stretches to match with what the bones are doing, just because it looks better and it's easier to read what's going on. Especially if you have joints turned off and you do this, it's hard to read if the geometry is not stretching correctly. So let's go ahead and fix that. But before we do, we'll save the scene again. We'll choose foot rig 10. So when connecting the leg geometry, we want to make sure that it'll scale along with what the leg joints themselves are doing. But if we take a look at how our joints are scaling, you'll remember we're actually using the translate x of the child joint to modify the joint's length. See here, this is the length of the original scale, or the original joint, and then the actual length is the a translate x divided by the original translate x. So that's how we're getting the length. That means when the joint is in its default position, it has a length of quote-unquote 1. And as it grows, the length is going to increase, and as it shrinks, it decreases. We can hook up this quote-unquote length to the scale of the geometry and get the geometry to travel along with the joint. But in order to do that, first we have to get the geometry so that its pivot is in the same location and orientation as the joint itself. Right now, if I select the geometry, which I can't do because we've set our do not touch layers up correctly, But if I select it here, notice the pivot is way off over here. That's not what we want. We actually need the pivot to be up at the top there. So to do this, we're going to select up leg joint and up leg geo, and then we're going to copy the pivot. Now the geometry has the pivot in the right place. Then we're going to go Modify, Freeze Transformations, Option Box, just with the geo. And we're going to choose everything, Translate, Rotate, and Scale. Freeze those transformations. Now this geometry is aligned with the joint, and its scale is set to 1, so that it's all aligned correctly. Do the same thing for the lower leg. Select low leg joint, low leg geo, copy the pivot, then just select the geo, modify, freeze transformations, and now it's aligned correctly. So what we're going to do now is connect the scale of the geometry to the translation of joints. You can do this using the multiply divide utility node or using an expression. For speed, the best way to do this is with multiply divide, as it will evaluate faster than the expression itself. Excuse me. But for ease of understanding of what we're doing, we'll create an expression to drive the scale of the geometry. So in order to get the scale of the joints, we need to divide the current length, that is, for example, the low leg joint translate x, by the original translate x value. To do that, we need to know the exact value of translate x. In order to get the exact value, we're going to use the getAttr command. The getAttr command looks like this: getAttr object.attribute. What that means is we're just going to get the value or the attribute of whatever this object is. So for example, if I did getAttr L low leg joint translate x, that's going to give me a value of 0.497175, which is the length of the basic joint. So let's go ahead and copy that. And let's also modify this command, getAttr, and we use it on the foot. L foot joint translate x. And that's the length of the bottom leg. And that's 0.0. Okay. We now have the values for our expression. So let's go ahead and create a scale expression. We'll go Window, Animation Editors, Expression Editor. Bring that up. Create a new expression. And we're going to call this L leg geo scale expr. And what we'll do is we'll say up leg scale is equal to L low leg joint translate x, which is the value of that joint, so we want to grab that, divided by the original length, which is going to be this. Copy that, paste that. Great. Cool. Then we'll have low leg scale is going to be equal to L foot joint tx divided by that. Okay, so what this means is when the leg is at its normal length, it's going to be its default size divided by the original size, which means it's going to be a value of 1. That'll be the scale value. We're just normalizing the scale here. And then we'll do the same thing for the lower leg. When the foot's at its default size, we get its value, and we're done. Geometry is going to have its default scale. Now we do L up leg geo scale x is going to be equal to up leg scale L low leg geo dot scale x is going to be equal to low leg scale. Cool. So if we take the foot now and we scale it, see how the geometry stretches? And that's all because we're just telling it to follow the length of that foot control. So it does it automatically for us. Let's go ahead and save this. File, save scene as. 11. Alright, so is our outliner cleaned up yet? Let's take a look. Close all this up. Sort of. We've still got this L leg geo here that needs to be taken care of, so we can select that, delete it. We don't need that anymore. And one last thing we need to do before we finish. Notice that right now our leg curves are the same color as a default NURBS curve, whereas we've got all these other really cool layers for everything else. We need to make sure that our layers are set up correctly. Okay? So let's go ahead and fix that. So we're going to create, so we've got the L anim layer. So I'll select the foot control here. Let's first turn on our do not touch layer again. And we'll choose right mouse button, add selected objects to L anim layer so that foot control's in the right place. Let's go ahead and change our settings. Anim, turn on the knee visibility on, select that, L anim layer, add that, set that back off. Let's switch over to FK mode, choose that joint, add selected objects. There we go. Let's go ahead and set this back to the default so we're in IK mode. Cool. And now finally, we need to make sure that we can move the rig to any position and orientation and have it work. So, because we followed all of our rules for dealing with scale by using that global scale attribute, I can come in here and scale this up, whoop, and then pick the hips and move it, and the leg works correctly as we expect, as do all of our different controls. So our rolling works, and everything stretches correctly. And that's again because we followed our same rules that we've been setting up from the beginning to make this work correctly. So let's save the scene as JJ version 5. Alright, so we made sure the animator could only select what we wanted them to. We cleaned the rig presentation and we can move it around. So what did we do? Well, we looked at the reference, we determined what was required for the leg, we tested a couple of solutions, we analyzed them, created a clean rig that follows our guidelines, we tested the rig, and now your next step is to deliver the rig to the animators to work with.